Good morning, students. So welcome back. So last time we have talked about the surface areas of cuboid, cube and cylinders. Now based on these formulas, let us solve examples, some of the examples from exercise 11.3. Okay, so second one from that, a suitcase with measures 80 centimeter into 48 centimeter into 24 centimeter is to be covered with a tarpaulin cloth. How many meters of tarpaulin of width 96 centimeters is required to cover 100 such suitcases? Now see, suppose this is the suitcase, okay, and I want to cover the tarpaulin. So what I am going to do? So I am going to cover this all area. So what is this? Yes, total surface area. So I know the length, I know the breadth, I know the height. Can I find out the material required for one suitcase? Yes, it will be equal to the total surface area of this suitcase. Now, how many such suitcases are there? There are 100 suitcases. So find out for material required for 100 suitcases, right? Now, the tarpaulin required, we have to find length of it and breadth of it is given. So definitely it is rectangular in shape. Now do you know the area of a rectangle? Yes, area of a rectangle is length into breadth. Now we know area of this tarpaulin is equivalent to the material required for 100 suitcases. So I know area, I know breadth, I can find out the length. This is what the theory for solving the example. Okay, so let us start solving. Tarpaulin required for one suitcase, that is equal to total surface area of suitcase. So that is equal to 2 into bracket L into B plus B into H plus L into H. Okay, now because it is cuboidal in shape, okay, you can see here length, breadth and height, all the three dimensions are different, so it is cuboidal in shape. Okay, so 2 into, what is the length? 80, breadth 48 plus breadth is 48, height is 24 plus length is 80, height is 24. Okay, now so 2 into 8 8s are 64, 6 carry on, 8 4s are 32, 32 plus 6, 38 and 0, so 3840. Okay, plus now 24 8s are 192, you can check it. 8 4s are 32, 2 3 carry on, 8 to the 16 plus 3 19, so 192, 19 carry on, 24 4s are 96, 96 plus 19, okay, 9 plus 6 15, 1 carry on, 9 plus 1 10, 10 plus 1 11, so 1152. Okay, now 80 into 24, so 24 8s are 192 and 0. Now add this all. Okay, so 2 into 0 plus 2 2, 2 plus 0 2, then 4 plus 5 9, 9 plus 2 11, 1 carry on, 8 plus 1 9, 9 plus 1 10, 10 plus 9 19, 1 carry on, 3 plus 1 4, 4 plus 1, 5. 5 plus 1, 6. Okay. Now, that is equivalent to 2 twos are 4. 2 ones are 2. 9 twos are 18. 6 twos are 12. 12 plus 1, 13. So, this is the tarpaulin material required for one suitcase. Okay. So, now how many suitcases are there? There are 100 suitcases. Therefore, tarpaulin required for 100 such suitcases. So that is equivalent to 13,824 multiplied by 100. Okay. So that is equal to 1382400 centimeter square. Okay. Now, we want to find how much tarpaulin is required. So this is the area. Okay. Now, length of the tarpaulin we want to find. Okay. So area of tarpaulin is equivalent to length into breadth. Okay. Now, this is the area of tarpaulin required. So, therefore, 1382400, that is equal to length into breadth. Breadth of tarpaulin is 96. Okay, so 13,82,400 centimeters square. That is the area of the tarpaulin required. Okay, now I want to find length. So length is equal to 13,82,400 upon 96. Okay, now what can we do? Reduce it. We don't know the tables. 96, I too don't know. So let us reduce them. Okay. Now, can I divide by 4? Yes, we can. So 4 2s are 8, 4 4s are 16, 4 3s are 12, 1 remainder, 18, 4 4s are 16, 2 remainder, right? 4 5s are 20, 2 remainder, so 24. 4 6s are 24, 4 zeros are 0, 4 zeros are 0. Okay. Now, again we can divide by, can we divide by 4? Let us check it. 4 8 are 32, 2 25. Yes, we can divide. Okay, so 4 6 are 24, 4 8 are 32, 2 remainder, so 25. 4 6 are 24, 1 remainder, so 16. 4 4s are 16, 4 zeros are 0, 4 zeros are 0. So what you got? Length is equal to 86,400 upon 6. Okay, now whether it is divisible by 6, let us check it. Okay, so 6 1s are 6. 14 plus 4, 18. Yes, it is divisible. Test of divisibility by 2 and 3. So this is divisible by 2 as well as 3. So definitely it is divisible by 6. It has to be. So 6 1s are 6. 6 1s are 6. 2. 26. 6 4s are 24. 2 remainder. So 24. 6 4s are 24. 6 zeros are 0. 6 zeros are 0. Okay. So L is equal to 14,400 centimeters. Okay. Now it's too lengthy, so convert it, it is too big, not lengthy, it is too big, so convert it into meters. So what you will do, divide by 100, because 1 meter is equal to 100 centimeters. Now I want to convert centimeters to meters, so I will divide by 100. So what I get? Yes, length is equal to 144 meters. So how much tarpaulin is, what is the length of the tarpaulin required? 144 meters. So therefore, the length of tarpaulin required is 144 meters. Okay, I hope you have understood. So let us move to the next example. So see, fourth example, Ruksar painted the outside of the cabinet of measure 1 meter into 2 meter into 1.5 meters. How much surface area did she cover if she painted all except the bottom of the cabinet? Okay, now the figure is given in your textbook. Just I am taking this as an example for the cabinet. Now what she did, she want to paint this, except the bottom she painted all the area. So see here, this is not painted. So the part which is painted, area to be painted, how we can find it out? See here, this is the length, this is the height, and this is the breadth. So bottom is not painted, only top is painted. Now bottom and top, they are same. So L into B, only one time. Then rest all 2B into H. This is L, this is H. So L into H and L into H. So 2 times L into H. And B into H. This is breadth, this is height. 2 times B into H. And this is only one time because base is not painted. So L into B only one time. So this top. Okay. So that will be the area of the what it is cabinet which is to be painted. Okay. So what we'll do, first find out area of the cabinet to be painted. So as I have said, L into B plus 2 into B into H plus 2 into L into H. Okay, only top, rest all surfaces we are going to take. Now, do I know the length? Yes, length is 2, breadth is 1. So 2 into breadth is 1, height is 1.5 plus 2 into length is 2, height is 1.5. Now I know the tables. 2 ones are 2 plus 2 ones are 2 and 15 twos are 30. But it is 1.5. So decimal point after one digit. Right? Plus 2 twos are 4 and 15 fours are 16. But there is one decimal point. The one digit after decimal point. Okay. So here decimal point after one digit, that too from right hand side towards left hand side. Okay. So 2 plus 3, 5. 5 plus 6, 11. So 11.0 meters square. So that is the area of the cabinet to be painted. Okay. So area of the cabinet to be painted. So final answer. How much surface area did she cover if she painted all except the bottom of the cabinet? So therefore she covered 11 meters square area of the cabinet okay. That is the answer. Okay. Now next example. Now say fifth one. Daniel is painting the walls and ceiling of a cuboidal hall with length, breadth and height of 15 meters, 10 meters and 7 meters respectively. From each can of paint, 100 meters square of area is painted. How many cans of paint will she need to paint the room? Okay, so here again, suppose this is the cuboidal room. Now she paints all the walls, so lateral surface area and plus ceiling of the wall. Okay, but we don't paint the floors, right? So again, L into B, bottom we will not take, but top L into B we will take. And we know the lateral surface area, what it is? 2 into bracket L plus B into H. So that we can use. So that is what our plan is. Now from that we will get surface area of the cuboidal room to be painted. And once I know the surface area, I know how much amount of area can be painted from one can. So number of cans required will be equal to area to be painted divided by area painted in one can. And from that I can get number of cans required. So that is what the concept is. And using that we will solve the examples. So let us solve it. Okay. Now, so here area of cuboidal wall cuboidal room actually to be painted. So that is equal to lateral surface area of room plus area of ceiling. Okay, because base or bottom we are not going to take into account. Now lateral surface area 2 into bracket L plus B into H plus area of ceiling, it is similar to the base, so it will be L into B. Okay, now 2 into bracket, what is length? 15. What is breadth? 10. So 15 plus 10, height is 7 plus L into B. So 15 into 10. Right? Now 15 plus 10, 25. So 2 into 25 into 7 plus 15 tens are 150. Now 25 twos are 50. 57s are 350. Okay? Okay? Now plus 150. So that is equivalent to how much? 0. 5 plus 5, 10. 1 carry on. 3 plus 1, 4. 4 plus 1, 5. So 500 meters square. This is what the area of the cuboidal room to be painted. So we got now. Now what is given? Area painted from one can is given. How much it is? Yes, 100 meters square. So from that I can find out number of cans required. That is equal to area to be painted divided by area painted from one can. Now, what is the area to be painted? 500. What is the area painted from one can? 100. So 0, 0 cancelled. Answer is 5. So how many cans are required? 5 cans are required. Therefore, 5 cans are required to paint the room. that is the answer. I hope you have understood. Let's move to the next example. Now see sixth example. Describe how the two figures at the right are alike and how they are different. Which box has larger lateral surface area? Okay. Now, if you see both these figures, one is cylinder and the other is cube. So what is alike between them? See here, what is the height of the cylinder? Yes, 7 centimeter. And here, height of the cube, no doubt it is cube. So this is length, this is breadth and this is height. All are equal. Hence it is cube. But what is the height here? 7. Here height 7 and hence they are alike because their height is same. Now what is the difference? What is the difference? This is a cylinder and this is a cube. Hence these two figures, they are different. Okay. So answer to the first question. Describe how the two figures are alike and how they are different. So here we can write the two figures are alike as they have same height, that is 7 centimeters. Okay, now their difference. The two figures, on the other hand, the two figures are different as one is cylinder and the other is cube. Okay. Now this is our first question, answer to the first question. Now second question, what they ask, which box has larger lateral surface area? So lateral surface area of cylinder. First we will find out. Now for cylinder, before finding out the lateral surface area, is the radius given? See what is given. For cylinder, what is given? Diameter is given. D is given 7 centimeter and height is given 7 centimeter. Is radius given? No. So I need to find out the radius first. So radius, what it is? D upon 2. So 7 upon 2. That is 3.5 centimeters. Right? Now I can find out lateral surface area of cylinder. What is the formula? Lateral surface area means curved surface area. So what it is? 2 pi r h. Okay. Now what is the value of pi? If it is not stated, we should always take 22 upon 7 as per the need. Okay. And now 22 upon 7 why I am taking? Because radius is also, radius is 3.5. It can be divided by 7 as well as height is 7. So it is cancelable. Okay. So 7 ones are 7. Now 2 into, I know the table of 22. 22 5s are 110. 11 carry on. 22 3s are 66. 66 plus 11. How much? 77. Decimal point after one digit. So it becomes 77. Now 2 7s are 14. 1 carry on. 7 2s are 14 plus 1. 15. So 154 centimeter square. That is the lateral surface area of cylinder. Now, lateral surface area of cube. What is the formula? Oh yes, 4L square. Okay, now 4 into L. L is what? 7. So 7 square. And 7 square is 49. Right? And 9 4s are 36. 3 carry on. 4 4s are 16 plus 3. 19. So 196 centimeter square. So, किसका lateral surface area larger है? Cube. Okay. So our final answer. So which box has larger surface area? So cube has larger surface area. Okay. So I hope you have understood how to solve. Now let's move to the next example. Now see 8th one. The lateral surface area of a hollow cylinder is 4224 centimeters square. That's what I have written here. It is cut along its side and form a rectangular sheet of width 33 centimeter. Find the perimeter of rectangular sheet. First understand the concept what it is. Suppose this is the cylinder, okay, right? This is the cylinder. Now see, this is circular part, this is circular base or top, whatever it is. Now, do I know the circumference of this? Yes. What it is? 2 pi r. Am I right? Now, if I cut it, this is the height. This is the height of the cylinder. If I cut it along this height, so if I will cut it along this height, see what happens. Okay. So, if I cut it along the height, this is the length, it becomes 2 pi r, and this is the height, that is the width of the rectangular sheet, that becomes the breadth. Okay, and so here breadth of the rectangular sheet 33 centimeter, height of the cylinder 33 centimeter, because that height is equivalent to the width of the rectangular sheet. Okay, now so first we need to find out length of the rectangular sheet. So how to find out? So for that, as I have said, this length is equivalent to circumference of that circular base. That is, length will be equal to 2 pi r, but I don't know radius. So first thing is to find out the radius. So how to find radius? Lateral surface area of hollow cylinder is given. Do I know the formula? Lateral surface area? Yes, 2 pi r h. I know h, height is 33. I know lateral surface area. I know value of pi. Can I get value of r? Yes, I can. From that I can find length of the rectangular sheet. That is, L is equal to 2 pi r. Okay, so I know radius, I know value of pi, I can get length of the rectangular sheet. And once I know the rectangular sheet length, I can find the perimeter of rectangular sheet. It is 2 into bracket L plus B. So that is what the plan is. Okay, so let us solve the example as per the plan. Okay, so lateral surface area before that we'll just mention one sentence here. When the cylinder is cut along its height, its height becomes the width of rectangular sheet. And circumference of circular face becomes the length of the rectangular sheet, so that you will remember what we have done. Okay, now we will use this lateral surface area of cylinder. What is the formula? Yes, 2 pi r h. Now, do I know this lateral surface area? Yes, I know that. 4224. That is equal to 2 into. Now see, I don't know the radius. So, 22 upon 7 into r into height. Height is 33. Okay. Now, bring this to the other side. So 7, when it comes to this side, it will be in multiplication, and 2, 22 and 33 will go in the division. Okay. So therefore 4224 into 7 upon 2 into 22 into 33, that is equal to r. So start dividing. 2 ones are 2, 2 twos are 4, 2 ones are 2, 2 ones are 2, 2 twos are 4. Okay. Now, do I know the tables? I know the tables. Right? 11 twos are 22. 11 ones are 11. Remainder 10. Okay. 21 minus 11, 10. Okay. So it becomes 101. So 11 nines are 99. 101 minus 99, 2. So it becomes 22. So 11 twos are 22. So what you got? R is equal to 192 into 7 upon 2 into 33. Okay. Now, again, 2 ones are 2, 2 nines are 18. Okay. Remainder 1. 2 6 are 12. Okay. Now, 3 ones are 3, 3 ones are 3. And here, 3 threes are 9, 3 twos are 6. So R is equal to 32 into 7 upon 11. Don't do anything here. We are not requiring what is the answer of the radius. We will use this in the finding out the circumference. See how. Now see. Length. So length of rectangular sheet. That is equal to. So we have said that it is equivalent to circumference. So circumference of circular base. Circumference of circular face. Right? So that is equal to 2 pi r. Okay. Now see. 2 into 22 upon 7. What is the radius? 32 into 7 upon 11. I hope you might have understood why I have not cancelled them there. I may get the answer in decimal point, and then it may become difficult. So to avoid that, now see, 7 ones are 7, 11 ones are 11, 11 twos are 22, right? So what I got, 2 twos are 4, 4 into 32. Now 4 twos are 8, 4 threes are 12. So 128 centimeters, that is the length of the rectangular sheet. Can I find now perimeter? Yes, I can. Perimeter of rectangular sheet. Okay. So that is equal to what? 2 into bracket L plus B. So that is 2. What is the length? 128. What is the breadth? Breadth is 33. So 2 into 8 plus 3, 11. 1 carry on. 3 plus 2, 5. 5 plus 1, 6. And 1. So 2 ones are 2, 6 twos are 12. 2 ones are 2 plus 1, 3. 322 centimeter square. So therefore perimeter of rectangular sheet is 322 square centimeters or centimeter square. So dear students, I hope whatever the examples I have taken, you have understood. Follow the plan. First prepare the plan, what you want to do. And then go for solving the examples. It becomes easy. Without thinking, don't solve it. You may make mistakes. Because at that time, I don't know what I'm doing. So first find out, first prepare the plan, what we need to do, what is given. And from that, what we need to do. And then it becomes easy to solve such types of examples. Now same examples, they will be continued in 10th standard also. So the difficulty level will be slightly high. Okay, and so prepare the plan and solve the examples. So try to solve the remaining examples as homework. So let us stop here today and we'll meet in my next video. Till then, goodbye. I will write the homework here before that. Okay, so first I will write the homework. So homework, exercise 11.3, example number 1, 3, 7, 9 and 10. Try to solve them. Okay, so let us stop here today and meet in my next period. Till then, goodbye. Have a nice day. Thank you.